Welcome to Queen Mary, University of London. We've got a number of people that have signed up. We've got over 800 people that have signed up tonight. We've got about 150 in the room and we've got over 600 online, and we're expecting more to join us. Now, it's great to see people online because you are represented from 40 countries across the world. So it's great to invite you virtually into Queen Mary, University of London. Now, as we know, the university has got a long, proud history built on 4 institutions. That's the London Hospital Medical College, that's St Bartholomew's Medical College, Westfield College, and Queen Mary College. And of course, you can go back to 1785 when the first of those was formed, which was the London Hospital Medical College. And it was formed as part of the London Hospital here in the East End in Whitechapel to provide hope and opportunity by providing medical care to the less privileged population within the East End. Then, of course, we got St Bartholomew's Medical College, which was formed in 1791. But you can go back to 1123 when St Bartholomew's Hospital was formed. And that was formed to provide hope and opportunity to the population in the City of London that were less privileged, and to provide that hope and opportunity through medical care. Then, of course, we got Westfield College, which was formed in 1882. Now, Westfield College was formed to provide education for women, because at the time, there was inequalities embedded within our society, and education was only for men. What a nonsense. And of course, then Westfield College was formed to provide education for women. And then you've got Queen Mary College, and Queen Mary College was formed in the East End of London to provide hope and opportunity through education. And at the time, people thought it was a complete waste of money. What a nonsense. It was there to provide that hope and opportunity to the less privileged population in the East End of London. And of course, in 1995, all 4 organisations came together to form Queen Mary, University of London. And today, we remain true to our founders, which is to provide hope and opportunity, to open the doors of opportunity to everyone that comes through our doors, to make sure that we provide the environment so that they can flourish and reach their full potential. Now, we've come a long way since 1995. At the time, when the 4 organisations come together, we just had under 9,000 students. Today, we've got 33,000 students based in London, based in China, based in Malta, and based in Paris. On our London campuses, we've got 170 nationalities. And I say, where else can you find or meet so many different people from different traditions, different cultures, and different backgrounds? And it's that diversity that's so important, because it's that diversity of thought when people come together. And of course, when you look at the improvements of Queen Mary, when you look at the citations in science, engineering, and medicine, we're second in the Russell Group, behind Oxford. And I think that might be something due to our speaker tonight as well, that had a bit of a contribution towards that. We're associated with 9 Nobel laureates. We're 4th in the UK for spin-outs. And we carry out research in sustainability, energy, digital, AI, health, of course, in performance and the arts, and in creative industries. And of course, not only are we leading in research, we're leading in education as well. We were named the top university for social mobility, where we have people come through our doors from less privileged backgrounds, but then go on and achieve in their career those top jobs and change society. And as I say, Queen Mary was top for social mobility. In 2021, the Times and the Sunday Times named us as University of the Year, runner-up to Oxford, which again might be due to our speaker tonight that we're going to hear from. Of course, there's other awards that we won over the last 12 months for public engagement, which is embedded within our DNA. We were the only university to be awarded the Platinum Watermark for public engagement. No other university can touch us. Now, of course, the theme of tonight's presentation is all about COVID. And just to tell you what happened at Queen Mary, of course, our staff and our students come together. The campus was never closed down. We had 1,700 students that lived permanently on our campuses within London. And of course, some of you would know that Queen Mary was involved in setting up the Nightingale Hospital in London. And just before that, we had a conference call with Wuhan Hospital because of our links in China to learn from what happened in Wuhan and what happened in China. As I say, the campus remained open. I was really proud of all our staff that travelled in to support our students, but also our local community. We provided free hot meals to the local community during the difficult stages of graduation. And of course, our research to support the COVID fight nationally continued, and Mark Caulfield will say a few words about that at the end of tonight's event. And of course, it was great at the beginning of January where we could have an in-person graduation, where we had 7,500 of our students all graduate, and we had 2,000 guests turn up as well. And it was great to see all our students achieve the graduation. But of course, tonight's all about our guest speaker, Professor Sir Andrew Pollard. Now, Andrew, of course, and I know some of you are alumni here tonight and online, graduated from Queen Mary, University of London, and graduated from our founding partners, graduated in 1989. But of course, we're going to hear all about Andrew's work during COVID. As we know, in January 2020, his team worked every hour in the day to try and develop a vaccine, and it was approved in December 2020. An unbelievable feat, and we'll hear more about it this evening. I'm told that more than 2.5 billion doses to 175 countries worldwide have been distributed, but I'm sure you're going to give us updated figures this evening. But before we introduce Andrew, I would like to introduce our event chair this evening, and that's Dr. Vanessa Apea, who's a consultant in sexual health and HIV at Barts Trust, and of course, an honorary senior lecturer at Queen Mary, University of London. And Vanessa is going to control the proceedings this evening. So please give a warm welcome to Vanessa.
Thank you, Professor Bailey. So good evening, everyone, and both here and online. As has been said, I am Dr. Vanessa Apea, and I'm delighted to be your chair for this evening's event. So the COVID-19 pandemic, so we know that it's had a detrimental effect globally. And as we particularly reflect locally about the events of the past 2 years, we can't help but acknowledge that East London and its communities were at the epicenter of this impact, most prominently in the first wave. And as someone who was born and raised within the East London, it held true in my life and my family as well. And we also saw very clearly in our own homegrown research across Barts Health and QMUL that those at risk of acquiring and dying from COVID was not equally distributed, with those from, amongst others, people from Black, Asian and minority ethnic backgrounds, people from socioeconomically disadvantaged areas, people with disabilities and learning disabilities, and people who found themselves marginalized or excluded were at heightened risk. But the COVID-19 vaccination brought an intervention with powerful protective potential. But there were concerns from the very start that some populations at high risk from the disease were those that may be underserved by these campaigns that had happened previously in the past as well. And early data confirmed that vaccine uptake had been lower in these groups as well. This concern, hesitance, mixed feelings, these were all understandable, driven by a lot of misinformation and mistrust. And this set in motion tremendous efforts across grassroots organizations, academic institutions, QMUL at the root of it, local authorities, primary care, NHS trusts, social care, to challenge misinformation and provide support so people could make informed decision making. And I believe there has never been a better example how authentic engagement is vital to efforts to achieve equity. And one of the biggest concerns was, how can we trust something that was made so fast? And as part of this work locally, Dr. Collier and myself presented to the general public at the Science Museum Leeds. And in fact, the story of Professor Sir Andrew Pollard and the development of such a powerful narrative to convey and provide assurance to the public. So I am particularly honoured to have the opportunity to hear directly from our own QMUL alumni, to hear about his role in the development of the vaccine and the wider pandemic response. So in terms of this evening, what's our format? So we will hear from our alumni for about 20 minutes, and then we're honoured to have a conversation style question and answer. This will be about 40 minutes, so get your questions ready. We've also had questions come in already online. And then afterwards, we'll be handing over to Professor Sir Mark Caulfield to give some closing remarks before we head out for a drink. And it will be great to have a chat with some of you there. So right now, it gives me great pleasure to formally introduce and hand over to Professor Sir Andrew Pollard. Sir Andrew is the director of the Oxford Vaccine Group in the Department of Paediatrics at the University of Oxford, and an honorary consultant paediatrician at Oxford Children's Hospital, and also a fellow at St. Cross College. He received a knighthood in the Queen's Birthday Honours in 2021 for services to public health, especially in the pandemic. Professor Sir Andrew Pollard, over to you.
Thank you very much. It was 1983 that I made my trip to London to start my medical course. And as I'm sure you can imagine, I was quite a nervous 18-year-old on my way here. I actually feel rather similar to that this evening, actually coming on the train to come and give this talk to all of you. Of course, that was 1983. And I was on my way here to St. Bartholomew's Hospital Medical College, which is where I studied medicine. And as you heard in the introduction, the hospital's coming up to its 900th anniversary. And it's great to see people who were there at its founding 900 years ago in the audience, certainly looking around here. So we have the slides up. We have the slides up. Great, thank you. So I thought I would start off just by showing you a photo of what I looked like back then. That's me there. And you can see from this that I haven't changed at all over that period of time. And of course, I did spend a lot of my time at medical school actually in the mountains. This actually was in 1988 in the Indian Himalayas. But I spent probably too much time in the mountains and not enough doing stuff at Barts. Now, I thought I'd start off just by talking a little bit generally about the vaccines. And you can see here on this slide that there are very many different types of vaccines that we actually have today. And we're enjoying those, which is what's given us the incredible change to where we are today in the pandemic. Now, I don't know if I point at these, whether people online will see it or not. And in fact, it doesn't matter because the pointer doesn't work. So what you can see here is that there are the old-fashioned types of vaccines, like the inactivated vaccines, which are listed there, which are just the whole virus grown up and killed. that's like the polio vaccine that we use today. The protein vaccines, there's many types of protein vaccines that we use. All the medics here will have had a hepatitis B vaccine, which is a protein vaccine. We haven't used those widely in Europe, but there are recently some of those licensed. And the RNA vaccines, which we're all very familiar with, that are shown here, most of the doses come from Pfizer, with some from Moderna. And then viral vectors, which are the Oxford-AstraZeneca vaccine, Johnson & Johnson, and indeed various others that I've not put on here, because on this is just those which have been approved so far by the World Health Organization. So there are many different types of technologies that have been used to help fight this virus in the pandemic. And the impact of that, as you can see on here, is a vast number of doses that have been now distributed around the world, 11.6 billion doses when you put all of those together. And so it feels in many ways like there's been this incredible success. Everything's worked. We've been in a pandemic where we've got all those doses out there, so many successes. But the truth is that there have been huge challenges for most of the products that have been developed. In fact, there are 349 vaccines that have been developed, and we only have 8 that have made it through to the World Health Organization approval. It'd be great to talk more about that, but we don't really have time for that this evening. But it's just an important reflection that we have been incredibly lucky in this pandemic to actually have got some vaccines over the line because of all of these challenges there are in producing them. On this slide and the next one, just to give you an idea that there's this wide array of products. Obviously, there's 8 I mentioned that the World Health Organization have approved, but beyond that, there are many others which are approved in narrower jurisdictions that have not yet met the criteria for global approvals. And I'm always proud to show this slide that the Oxford-AstraZeneca one is the one that's most widely distributed. Actually, it's in 180 countries now, and we're just at about 2.8 billion doses that have been distributed. And I'll come back to the reason why that is in a moment. But you can see here that there's a number of others. And on the next slide, you see that there are some that are only in one country. But all of these have been critical to contribute to the protection that most of the world now sees. That one hasn't projected very well for some reason. This now brings us right back to the start of the pandemic. So this is a New York Times headline. I put this up to show you on widely read. And this is from the 11th of January, 2020. And it's a great headline, essentially saying that there's this pneumonia cases in Wuhan causing deaths, but don't worry because it doesn't spread from person to person, which obviously is very good news if that was true. Now, the fascinating thing about that date is that is the date that we received the genetic code of the virus in Oxford from the Chinese scientists. And so they knew that they'd got a virus that was spreading. They didn't actually know we were on the verge of a pandemic. None of us did. But it was sent to our team in Oxford, and Dame Sarah Gilbert and Professor Theresa Lamb received the sequence. And because they were already working on a coronavirus vaccine, they could switch in the code for this new virus as a sort of an interest project, because we didn't know it was going to be needed. And they did that in 48 hours, did a little bit of work on it, and then thought about whether it was worth actually going and making any of the vaccine ready to do trials. And of course, over the next few weeks, we saw cases in Italy, and then by February, we were getting cases here in the UK, and everything really got going at that point. And you'll remember that as we moved through the early part of 2020, we saw these horrific pictures, and you were talking about that in the introduction, of people with very severe lower respiratory COVID and fighting for their lives. And that image is something which is worth just holding in your mind, that this during 2020 reached a point where every single day about 10,000 people worldwide were dying. So you can imagine the enormous pressure on the vaccine team, knowing that if they were slow, that's another 10,000 people for every day that there wasn't a vaccine available. And of course, we also had these huge headwinds because the data that have been looked at over the last few decades had really shown, based on the 1918 pandemic, that vaccines were very unlikely to have an important role in a pandemic. because most of the people who are going to be infected would have been infected and died before you could make a vaccine. And this has been very much modeled. I've been in many of those meetings over the last 20 years. It was really felt not possible. The extraordinary thing was how well lockdowns worked in buying time for vaccine development. And the other huge issue was that really the model of modern vaccine development is that it takes around 10 to 15 years for every new product. But even the most optimistic from Tony Fauci here was that it would be about 18 months. Most of the UK media said it would be a few years. And of course, as you think about it, today we're 2 years on, so most of the world has been infected, which means that most people who were going to die would have died by now if we'd waited till now to have a vaccine. So this is too slow. But the reason why things were able to move so quickly was two things. The first was that we had these platform technologies already to go. The RNA vaccines, everyone thinks they're new. Moderna started 10 years ago. BioNTech started more than 10 years ago. There's been huge amounts of work to work out how could you use RNA to make vaccines. And then it was just ready at the moment this pandemic arrived. The viral vectors that we worked on, the first example of a viral vector vaccine was 40 years ago. And we've been working on our particular platform over the last 15 years and have multiple vaccines, not just coronavirus vaccines using it. I work on plague. We have a plague vaccine based on this technology. So none of that was new. The platform wasn't new. And the second important component of this is that coronaviruses were already on our radar. We knew how to make a coronavirus vaccine. Everyone's heard of the spike protein. The spike protein was known to be the critical component of a vaccine that would then allow us to make a protective vaccine. So we were extremely lucky that it's a coronavirus. 20 years ago, SARS emerged, killed about 11% of those infected. 10 years ago, MERS, another coronavirus, emerged, killed 35% of those infected. And that had really driven the vaccine community to say, well, we've got to work out how to make coronavirus vaccines. And so we had done. We'd made them. They'd been tested in humans before the pandemic. Unfortunately, there are a lot of viruses out there that we don't have any of this data on and would put us in a very different situation if they were the ones causing the pandemic rather than this coronavirus, which made us, we were very lucky. The other thing I wanted to just mention here is that the pandemic mortality is less than 1%. And that really may not be the case next time. So this is the development program. You can see the sequence arriving there on the left on the 11th of January. And we really got going in February because we recognized there was a pandemic. There's a lot of people who work on vaccines, all working in their silos in Oxford, in their interest areas. And I think the critical moment was when we got together and realized this was a bit bigger than us with our academic egos, that we all needed to get together to set up different teams to be able to drive forward the development, the manufacturing, which is the heaviest lift, the hardest bit of producing vaccines, the clinical trials, which arguably is one of the easier parts of it, which I led, and the animal studies and the laboratory work, which Theresa Lamb led. So those different components of the development, we just stole everyone else's staff and put them in a management structure that allowed us to then lead those teams. So the team for the clinical trials globally was about 2,000 people. And here you can see the team across the UK. One of the reasons why the UK has produced more of the science in the pandemic than any other country is because we have a clinical research network. The fact that we could stand up, when I called them PIs around the country, I gave them 3 weeks to be ready for a phase 3 trial, and they got their sites ready. We trained all of the nurses and the doctors about how to give vaccines, and they got going in 18 NHS sites across the UK. But importantly, one of the critical steps was to say that if you're going to have a vaccine where we really want it to be globally distributed, you have to test it internationally. You have to test it in low-income settings, in middle-income settings, in ethnically diverse populations around the world, and in settings where there is geographical distribution, because particularly as we were making these decisions in April of 2020, we had no idea after the global lockdowns when the next wave was going to come or where. So having lots of sites across the UK and around the world meant that we were in a good position when the next wave came to be able to collect the cases. The way the trials are done is that you wait for cases to accumulate in the trial. You need somewhere between 100 and 150 cases. Hopefully, the ones, they're going to be mostly in the control group, not in the group that got the vaccine. And then you've got a successful vaccine. Brazil was the most incredible place to work. We enrolled 10,000 people there, the same as here in the UK, and a few thousand in South Africa. We also had sites being set up in South Asia to try and have that global distribution. But at that time, we started making a partnership with AstraZeneca, who were the company who came forward when we said that this has to be developed not for profit, because we wanted to take out the commercial incentive to sell the doses to rich countries. As soon as it's not for profit, we might as well give it to whoever most needs it, which, as we'll talk about, is much easier to work out how to distribute. And that is why the vaccine has been very widely distributed, because there was no commercial incentive to go to the high-income settings. And AstraZeneca were a fantastic partner in that. We couldn't, as a university, manufacture billions of doses. And so we needed a partner with a global network that was able to connect into the manufacturing sites. We set up more than 20 around the world, and that they could then support and to make sure the same vaccine, the same quality was being produced all around the world in those different sites. And the biggest of those was the Serum Institute of India, who's one of the key partners, the biggest producer of vaccines in the world. And so they were the main supplier to much of the region that they stay in, and the main supplier for Africa. And so for the first half of 2020, more than 90% of the doses which were distributed through COVAX, that's the body which gives global distribution of the vaccines, were coming from AstraZeneca, particularly from the partnership with Serum Institute of India. Unfortunately, or perhaps fortunately in some ways, the Indian government then put a blockade that meant the vaccine couldn't get out of India because they were facing the Delta wave with huge numbers of hospitalizations and deaths in India. And so the doses went to protect many people in India for that period of time. But it did mean that Africa got rather left behind. But that partnership across the world has been absolutely critical for that distribution. So moving to the right-hand side, I've mentioned the phase 3 trials, which started in June of 2020. And as we move through the year, we presented the first results at the end of November of 2020. And then the most enormous effort, which I've never been through before, in trying to put the data from 25,000 people together for a regulatory submission, which we did in a rolling way during December. And eventually the MHRA approved the vaccine at the end of December. But that was really important for the UK to have approval. It meant that the first doses here could be used just a few days later on the 4th of January. But in order to have that global distribution, we needed the World Health Organization to go through their approval processes. And that took the next couple of months. First of all, to have the European Medicines Agency give their approval, which was required by WHO before they then sanctioned use of the vaccine, and they made the policy recommendations for global use. And so 24th of February on the right there was really the most important day in my calendar, which is when the first COVAX deliveries left to go and be delivered in Africa. It's worth just mentioning that one of the strangest things about this, because I mean, my day job is making and testing vaccines, and actually in the pandemic, we've done the same as we normally do, but then you look out the window and you realize everyone's watching. And it's been an extremely unusual and bizarre experience to have not only the UK media, but the global media contacting us. And in fact, at one point, we had 18 communication staff employed just to deal with the inquiries, and we were getting more than 1,000 inquiries from journalists per hour at the height of it. It's unbelievable what we had to deal with. Unfortunately, we managed to put a wall around all of the scientists and have the comms team take and shoulder all of the burden of that. Quite astonishing. I wanted to just make one comment to one of the things I was asked to say about what might we do differently. And For me, one of the things that we should have done differently is we should have run bigger trials. And the reason for that is fairly obvious. You need, I said, about 100, 150 cases of COVID in order to evaluate the vaccine. If you have a small trial, it takes longer for those people to be infected. If you have a huge trial, then you get your answer quicker. And that we could only vaccinate 25,000 people, and that was difficult in itself because, first of all, in our facility in Oxford, I can only make 1,000 doses at a time. It's a 2-dose schedule, so for 25,000 people, you need 50,000 doses. So we went to an Italian manufacturer who we'd worked with before, and we knew they could make the vaccine, but they couldn't make enough, so they made some. Then, fortunately, a company called Cobra in Kiel here in the UK was able to come online eventually and build us up to our 50,000 doses to be able to run the phase 3 trials. So if we'd had the manufacturing capacity and run a trial of 100,000 instead of 25,000, we would have been through this much more quickly. And remember, I said 10,000 people globally were dying every day. A few weeks difference makes a huge difference to people's lives. And I think that's the real challenge for the future is how do you deal with the manufacturing capacity that you need in a pandemic that possibly you don't need when there isn't a pandemic. Of course, the added problem is the lockdowns make it more difficult to keep going. So this really was just making that point, so I shall speed on. Now, I mentioned manufacturing, and I think it's for people who work mostly with drugs, the manufacturing bit is not usually the hardest part because they're much easier to control and to have reproducible batches each time you make the drug. The chemical processes for most drugs are much more straightforward. Vaccines are biological materials, almost all. In fact, the RNA ones are about the closest that you can get to a drug rather than the vaccine. But to make, for example, our vaccine, you have to grow up mammalian cells in a big bag and then infect those cells with the adenovirus that is used as the platform for the vaccine. And you can do that on a small scale quite easily in the laboratory. To make it on a scale of tens of thousands of liters and to have the same product every time you do it is a huge manufacturing challenge, even for one facility. But to do that in multiple different settings around the world is hugely difficult. And one of the main reasons why vaccines have failed, or have come late in this pandemic, is because of those challenges of getting reproducibility and the same product at high quality over the course of the time. And so there were other trials which reported not that long after ours did, where the vaccines have only recently been approved because of those challenges for manufacturing. To come back to this issue about mortality and to think more about the situation that we've been in with this very low mortality disease. This was the Black Death in the 1340s as it arrived here in the UK, killing about half of the population of Europe over the next few years. So this was a disease, a bacterial disease spread by rodents, and it killed half of the European population. It took another 100 years for the population of Europe to return to where it had been before the Black Death. So that's just one example of what we could have been facing in this pandemic. And you can see here that we're probably now facing, the real figures are likely to be somewhere around 18 million deaths in this pandemic. We have clearly documented about 6 million deaths, but there's probably around 18 million globally, which is not as high as Spanish flu or the 200 million or so with the Black Death, but still pretty extraordinary figures. With the world's population today, just imagine where we'd be if it was 10% mortality or higher. And so the danger is that we all look at this pandemic and assume that the next one will look the same. But the truth is we need to think about what would you do in clinical trials if 30% of the population were dying? How would you run the trials? You wouldn't run them in the way that we did, and you probably would do some small-scale safety and then move into some sort of effectiveness study, rolling out and evaluating as you did. But we haven't thought through how that would work yet. We need to do that before the next pandemic comes. And there are very much some limitations in observational studies. They're much more difficult to avoid bias in them compared with randomized controlled trials. And actually, this pandemic has been built on randomized controlled trials across treatments and vaccines, and it's been enormously successful in doing that. And it's worth reflecting on the 1918 flu pandemic, where there was no intervention at all that could be used apart from physical distancing measures. And what we've found across many different products, this is too small to read, but essentially all of those dots on the right of these plots show that any vaccine that was picked off the shelf and has been studied has shown this high effectiveness. There's a little bit of variability, but they're incredibly effective in preventing COVID, preventing this severe disease. And here you can see in the UK data on the confirmed deaths, that since we've had widespread usage of vaccine, really deaths have become a very minor part of the overall story, as you can see on this slide. In those first two peaks, before we had widespread use of vaccine for any vaccines, the people there were dying of very severe lower respiratory disease. They were dying because they couldn't breathe, and many in intensive care, some without ever reaching hospital. Whereas now when we look at this period, which is really since Delta emerged and we had a highly vaccinated population, it's a completely different picture. Somewhere between a third and a half of those are not deaths from COVID. They're individuals who are infected at some point in the weeks before, but they've been admitted to hospital for some other reason. They've fallen off a ladder or have appendicitis. It's not due to COVID. There's another group, and the largest group, which is really important, are individuals with other health conditions, with comorbidities. And they're getting a mild infection or milder infection that is actually destabilizing them. It's making them their heart failure worse or their other underlying health condition worse, that's ending up with death. And then there's a much smaller group of those who can't respond to vaccines, who are actually suffering from the same disease that you see in the first two peaks. But that disease from the first two peaks has become a very rare entity. The intensive care units are no longer full of those patients, despite the enormous number of cases. So I just want to finish up mentioning some issues around equity. So you can see on this slide the global COVID deaths. And the good news you can see is it looks like it's a declining picture. There are fewer deaths globally, just as I just showed you in the UK. And increasingly on the right, these are actually people who've died with COVID rather than because of COVID. And the thing that's changed this picture, is partly that there are now 5 billion doses out there. But it's also partly that many of the people who were going to die have died already, and most of the rest have some immunity from infection of those who are unvaccinated. And so we're in a very different position today with such a huge spread of the virus, that the combination of virus infections and immunity and the vaccines means that we would expect that the deaths from COVID will continue to fall, except in some very rare exceptions, which we may talk about. But overall, this is something which I think will be a continuing trend, and it's reaching 5 billion doses. And it's particularly striking when you look at the number of cases, that we've got a huge number of cases, and yet the deaths are still falling. And that really underscores this issue that today, having the virus in the population is driving much less of a problem than before in terms of the mortality. And I think one of the really important points about this slide is that this is telling us something about our future. We have a future where we're living with this coronavirus. It will continue to mutate, find ways of infecting us despite some immunity. But the disease it's going to be causing is going to be largely now the milder infections. And so the groups that we have to think about and worry about are those with the underlying health conditions, who with the milder infections are still at risk of ending up in hospital and putting a burden on the health system. And as all those who work in the NHS here know, the NHS works at almost 100% capacity all the time. It goes over the edge every winter when flu comes. And so it's not very resilient in a pandemic. We now are going to have to reset that, because coronavirus is going to be there, adding to all of that stuff that was in the background. And otherwise, we're going to be continuously over 100% with the burden on the health system. So this was, from a global equity point of view, was actually exactly the same as we did here. This was the WHO position: start with older adults, those with health conditions, healthcare workers, just as we did here in the UK. But today, this is what the vaccine distribution looks like. So we very clearly failed to do that. In fact, what we did is we said, well, let's focus first of all on the rich countries, go down those ages, vaccinate down to childhood, where the risk is extremely low, before we vaccinate older adults in some other parts of the world. And now when you think that most of the deaths in the world have been in the over 65s, that actually the effort required in terms of doses to vaccinate all of the over 65s in the world would have been relatively easy to do as an early part of our efforts. But actually the way that things happened is we did not do that. We went down these age ranges to the younger age groups before thinking there's people who are over 65 in other countries who are at risk. And not surprisingly, that's entirely linked to the economic circumstances in those countries. So those with the lowest GDP have got the fewest doses, and at this stage in history, that's largely Africa. There are many other diseases which we need to be thinking about in the future. And we really need now to take the lesson of this pandemic, invest in the new vaccines for many of the diseases which could threaten us in the future. Anything about. We need to do more work on this. We were really lucky in this pandemic. We were dealing with a virus we knew about with a low mortality. And we were able to make vaccines at huge scale very quickly to make a difference in the pandemic. The fact that the first half of 2020, vaccines were being deployed will have prevented many deaths. In June of 2020, the G7 came, sorry, 2021, in June of 2021 last year, the G7 came together and said, we'll pledge 1 billion doses in order to make sure all of those other countries can have their doses. The problem was between June and the end of the year, another 1 million people died because those doses still haven't been delivered. And the difficulty is that if you want to stop people dying, you have to vaccinate them before they're dead. And that meant vaccinating in a fair way earlier in the pandemic. Huge pressures for all of the team, but it really has been an enormous pleasure to work with these fantastic international teams in delivering the clinical trials, but also the huge number of volunteers who come together to take part in these activities, and many of you will be working with those in your own clinical research. But here, at the beginning of the trials, we were saying to people, we don't know if the vaccine will work. We certainly don't know if it's safe. Can you come and take part? And 25,000 people did. And I think it's just incredible that those individuals have put us in a situation today where we're able to sit here and have a discussion together. Thank you very much.
Clapping, my mic went off.
Oh, you've dropped it again.
Oh, dropped it again. There we go. Bear with me. Perfect. I have to say a huge thank you. And I think everyone here will just resonate with what I'm saying, because where you started from in saying that we were lucky, but we had a long backstory. I think I wish that I had had that tagline during the vaccine engagement, because I think that's one of the most powerful statements, that people still didn't recognize that so much work had happened before. And there were many items that we didn't feel we were lucky in this pandemic, but it could have been far worse. And I think recognizing that is a really, really powerful narrative, but so much more to talk about. And I'm not going to hog all the limelight and the questions. So I have a number of questions which have come through online. So again, I want to thank our online participants, but now is your time. So do we have any questions from the audience? We have a roving mic that is around, and we've got our first hand that's up there. Oh, second hand. So I think we've got a lot to do. So if we go into the first, and if I could ask you to just briefly introduce yourself and then put the question ahead.
Hello, yeah, my name is Alex Safar. I just wondered, so you're talking about how manufacturing mRNA vaccines are slightly easier due to them being closer to drugs, and the AstraZeneca vaccine being harder to produce because it's a viral platform. So I wanted to ask, I know I'm missing a few factors here, but how come the Pfizer vaccine ended up being reportedly more expensive in terms of the individual doses?
Well, so the way that the pricing structure normally works for vaccines is based on what the companies decide to set it at and what they think people will buy them at. That's the normal commercial model. Perhaps just worth reflecting on how things actually work here in the UK, which is slightly different. When vaccine policy is being made outside of a pandemic in the UK, there's an analysis done which looks at the cost effectiveness from the perspective of the healthcare provider, in other words, for the NHS. And so that is an analysis that's assessing how much you're prepared to pay for the vaccine, for the savings that you get essentially for preventing the disease. And there's various thresholds agreed with the Treasury that is used. NICE uses a very similar process. The difference with vaccines in the UK is that if a vaccine doesn't meet those cost effectiveness thresholds, then it's not used. And so the companies, when they negotiate with the government, they usually know what the likely cost effectiveness level is, and they then, in the closed bids they do with the government, try to find some way of being very close to whatever that number is. And often the work is done by academics who publish it, so it's widely known what the figure is. So that means that vaccines in the UK are relatively cheap anyway, because they're the amount the NHS is prepared to pay for them. In a pandemic, that goes out the window because you're trying to stop something which has a much bigger impact. If you think about the billions of dollars every day which are being lost in the global economy, the effect that has, those analyses no longer make sense in the same way as they would have done. So actually governments negotiate, I'm sure, very hard with the companies, but they have a slightly different framework for doing so. With the AstraZeneca vaccine, we insisted from Oxford, being a publicly funded institution, that the vaccine should be sold at low cost, not for profit. And so that is the reason why it was such a low price. So its new phase, sort of beyond the pandemic doses and contracts, they're still having it at a very low cost, and it seems to be one of the lowest still.
Thank you. I think we had a question.
I think while the mic's out, it's worth saying that usually in business, investors don't allow the companies to do things not for profit. It's quite a tussle to do that. So the commercial model is actually quite important in that we might have had fewer vaccines if we didn't have the commercial model to drive some of that development. So the different models, they don't work for me, but they may be important.
Got a question related to that.
My name's Rob Alliker. I'm from Queen Mary here. Right at the start, well, for some time, I think some people have suggested that respiratory viruses, with time, tended to become more transmissible and less virulent, where others, particularly virologists, have said we should never assume that. I just wondered what your view was on that point.
Well, I think it's true that we shouldn't assume that, because one thing, we've never tracked a new pandemic in the same way as this to really have a good handle on that. Interestingly, in some ways, that is what happened with the 1918 flu, the Spanish flu, in that it caused several waves of disease globally, but then it became the seasonal flu for decades afterwards. Was it that the virus is really milder, or is it just that most of us had some experience of it? And so as our immunity waned, we were able to get infected again in the subsequent seasons. And that, of course, is also the complexity today, is that so much of the global population is either vaccinated or infected. When we look at these new variants and we say they're causing mild disease, it's very hard to pull that out from the immunity that's there in the population. The UK, more than 95% of people have got antibodies, either from vaccine or infection. So that means that to actually be sure when you're trying to work out whether disease is milder, is it that people are more robust because they've got immunity? And just to come on to the issue of what about populations that haven't met COVID yet? We have, I think, the best data at the moment from Hong Kong, where they pursued a zero COVID policy very successfully. And I think we're all feeling the problem is that you have to use that time to vaccinate the population so that when you do remove restrictions, you have a protected population. And unfortunately, in the elderly care homes in China, only 15% of people were vaccinated. And so when the latest Omicron variants arrived in Hong Kong, they've had huge mortality, intensive care units that look like ours did in March 2020. And they waited 2 years. I don't nation and compare with what we look like in March 2020, whether it's milder, but I think that's the sort of comparison that you would need rather than the way that we've been looking at it so far.
Thank you.
Great. Professor Kumar.
But worth keeping an open mind because it is entirely possible that you could have new variants which were able to cause more low respiratory disease, that it would only need to be able to infect those cells better to do that. Now, I don't think we would have much of a problem because we're already so immune. But if that went into a non-immune population, that could be much worse.
Thank you very much, Andrew. Thank you very much indeed. Sorry, my name is Praveen Kumar. Vanessa mentioned in her introduction about the ethnic minorities who rather had a bad time over it. I just wondered, has that any reasons why? Also, could you compare what happened here and say, for example, in India? And is there any precedence in previous pandemics that poorer people perhaps, or ethnic minorities have had the same problem? Thank you.
Thank you.
I think it remains quite a difficult question to answer. And it's not really my area of expertise, but we have looked at it specifically in immune responses. And whether you were in South Africa or Brazil or the UK, the immune responses are pretty similar to the vaccines. So the vaccines work the same across different populations. We see very similar levels of protection. But I think it does raise an interesting question, which unfortunately, Caucasians are a bit boring genetically. We are a bit boring genetically. And I think the relevance of that is that there are genetic associations both with side effects of vaccines and also with immune responses and protection. We've got some early data, which isn't published yet, suggesting some associations from our trials with particular genes, and both with differences in protection and differences in the immune response. So although I don't have the data, it's plausible that across different ethnic groups, which have different genetic backgrounds, you may see some differences in protection from vaccines and in the immune response. And in Africa, that's particularly interesting because it's the most diverse population in the world. And so it would be very interesting to see whether in different parts of the continent you see differences in immune responses and protection. I think the second bit to that question when you look globally is that the global population structure is very different. And obviously here in the UK, we're like that with lots of old people. But in low-income settings, the population structure is like that. And the data I've seen suggests that if you're in that peak of over 65s in a low-income setting, you're just as likely to die from COVID in Africa as you are in the UK. It's just that the numbers are much smaller because of the shape of the population.
It's so interesting. I think that that whole aspect of the immune response across globally, we're missing a lot of data because we haven't got that vaccine equity. So that learning that would be crucial in informing whatever pandemic is coming in the future, we don't have that. And I think that's another reason why I think that activism on vaccine equity is so important, as you alluded to earlier.
Yeah. But there are much stronger factors than ethnicity or income setting. Things like obesity, diabetes, these are really powerfully associated with risk. And those are the things we should actually deal with and to make a difference.
Definitely. Oh.
Mauro Perretti, pharmacologist at Queen Mary. Talking about the longevity of the immune response, are we going to receive a fourth dose?
A common question from online.
So if you look at the immune responses, they actually persist fantastically well. 2 years later, you can still see high levels of immunity in people who've been vaccinated. But it depends what you mean by immunity. If you are trying to prevent severe disease in a younger adult, so let's say under 60, who doesn't have any other health condition, then the vaccine, the data we have at the moment is that 2 doses of the vaccines, wherever you are working extremely well. We're not seeing lots of young people being back in hospital in that scenario. As you know, as you get older, there are more and more individuals who are frail, who have other health conditions. And for those individuals, it's infection that's the problem, because it destabilizes and makes them unwell. Some will have much weaker immune responses because they have a particular health condition or a treatment that does that. And so those groups almost certainly will benefit from boosters. But what boosters are doing is taking us from what's really pretty good immunity, pushing it up to a level which the immune system doesn't really have good persistence at. And so over the next few months, it comes down again. And we do this with flu every year. As the flu season comes, we vaccinate all of those people in the same groups we just talked about. We push the antibodies up, and you have about 30 or 40% protection. Sometimes 60% of it is really well matched to the circulating virus. And then you need to vaccinate again by the next year because the immunity's waned. And there's even data suggesting that if you just happen to have your dose just before the flu season arrives, so you're closer to it, you've got the higher levels, you're more protected than if the flu season's a bit late, and so you've already had some waning. And that's about preventing infection, not about preventing severe disease that we were talking about. So I think the vaccines work very well at preventing severe disease in those who've got a competent immune system. But we actually need ways of preventing infection, and that's much harder to achieve. And it doesn't seem that with our current technologies, we can actually maintain that beyond a matter of months.
Thank you.
Hello, thank you. My name is Henrietta Hughes. I'm a GP in East London. And just as Vanessa was saying about vaccine hesitancy, a lot of our patients felt very unhappy or uncomfortable. So I wanted to ask about your opinions about anti-vaxxers. Do you think it's philosophical, political, or other?
Well, I think that it's a poor term, because I think we tend to use it to incorporate a large group of individuals who have very different reasons for not being vaccinated. And most of the surveys that have actually looked at, as you know well if you're in primary care, one of the issues is always access, and that's particularly true with routine vaccinations. If you're a single parent in a high-rise flat and the baby clinic's only on a Tuesday, it's very hard to get there for the vaccine. So access, even in a setting where we've got vaccines in the surgery around the corner, is a problem, even more so in other parts of the world. The second, much bigger group than I anticipated in the pandemic has actually been people who are afraid of the needle, rather than what's in the vial, afraid of the needle. And that is difficult because it requires a lot more time. And we've got in the UK very experienced practice nurses who are good at doing that. But it's much harder to deal with that in mass vaccination clinics. But that's a group that really does need a lot of effort in order to reassure people. And of course, I'm sure you've seen lots of individuals with misinformation stories, and they also need time for explanations and for them to understand what's going on. The actual anti-vaccine group is relatively small. It is bigger, I think, now in the UK than it was. They're much more organised. But I don't think in the UK it's a particularly political movement in the way that it is in the US. It's a group. The communist sort of psychological background is conspiracy theorists. And it's very difficult if someone has an unshakable view to change their view. And in fact, some of the psychological experiments suggest that the more you try and persuade, the more entrenched those views become. So I'm not sure that we know how best to deal with an anti-vaccine individual in front of you in the clinic, what the best way to do is. But those other groups all have solutions that they just need quite a bit more time than we actually have in front of us.
It's interesting because quite a few of the questions online relate to how you feel about some of the things that were going on politically around you. And that was one aspect of, with yourself working day and night to develop a vaccine and then being met with such negative sentiments. How did that affect you and your wider team? What were your reflections, personal reflections about that?
Well, I think the political dimension was definitely interesting. And personally, I mean, it was a bit frustrating because what we knew was that we had a life-saving technology. In fact, all of the vaccines are. And any negative comments that came from politicians or in the media undermined our ability to save lives. And when we look into, for example, all the debacle in Europe, partly probably we know the UK was in a very difficult moment with Brexit having just happened, and some definitely political fanfare about a British vaccine at a time when Europe was in a very difficult situation. They didn't have enough supply of doses. Unlike the UK, which had ordered many different products in the hope that one of them would work, the European Commission only ordered a few. And fortunately, they did order ones that got licensed. But then they were very frustrated by the shortage of supply, and President Macron made some comments. So all of those things, it's difficult to understand. I mean, the politics was fairly easy. I don't know why Macron made the comments he did, but for some of the politics with Europe was easy to understand from a political perspective, but not easy to understand from a health perspective because of the damage it did. Now, a lot of that was reversed in Europe, and we do have Western Europe, a very highly vaccinated population. But for example, some of the stories were in West Africa, and they were never counted. And so the hesitancy in some of those countries is huge and still is there today because there wasn't the ability to go back and deal with them.
Thank you. Maybe at the front. I'm getting the eye contact, I can see people.
Mary Collins, is there a risk of the virus mutating to escape the present vaccines?
Well, the natural sort of evolution of this virus, in fact, of respiratory viruses in general, if they're going to survive, tends to be to escape the immunity in the population. There are some viruses which do that by subverting our immune response. With influenza and with COVID, the virus is mutating to get around the immune responses we have in our upper airway. But its driver to do that is that it continues spreading. I mean, if we block its ability to infect us, it would fizzle out. And so it has to evolve mechanisms to avoid that. And we've seen that through Alpha and Delta and Gamma, which was in Latin America. And now with Omicron, with its various variants, they are evolving to escape immune responses generated by vaccines or infection. But that's just normal. That's what viruses do. And that's why I say this virus is going to be with us. It'll just keep doing this.
Change the vaccine to counter new variants at some point?
So the problem is sort of, it's a flu-like problem, that with flu, we can, this time of year, look in Australia in the tropics, see what viruses are circulating for flu, and then the vaccine is made for our winter based on our best guess. We don't always get it right, but in the years we do, we have very good protection. The problem with COVID is if we look at the moment with sort of Omicron and its variants, but if we now start making vaccines for those, do a bit of testing, get them approved, we've got many months that would take with any of the products. And by that moment, as we've seen, these waves have been and gone. So do we want an Omicron vaccine this autumn? It seems to me possible, but unlikely. What we really need is some idea of a virus that has become seasonal, so that you can just do some logical planning of what to put into the vaccine, maybe have multiple different variants. But at the moment, if you ask people, well, beta, we haven't really seen that variant. We haven't seen alpha. We haven't seen much of delta. And it's all Omicron around the world. So what would you put in even a vaccine that had multiple variants in it? So that's the challenge at the moment. And so we're sort of stuck with the vaccine that we made at the beginning, because that works. It still boosts, it still provides some protection against these very different variants that emerge.
Great, thank you. Gentleman here.
Hi, I'm Desmond Alvarez, Queen Mary. I was just, thank you, Sir Alan, and Sir Andrew, about the presentation. I just wanted to ask about, you mentioned at the beginning that you got the information very quickly because the Wuhan group shared the information pretty fast. In terms of subsequently, was there a lot of then sharing between the different groups of what was happening with the results, and how on as you talked about, there are some issues with some people in the community. Was there an interest in trying to create variants that, or variations of the vaccine that allowed to deal with those specific issues?
So I'm not sure I quite got the last bit of the question about dealing with what? Dealing with?
So dealing with where people do have some issues with the current vaccine, and if there was interest in trying to adjust the vaccine so that it could deal with the issues that they have.
But what sort of issues do you mean?
One of them was like, it was a heart condition.
Oh, I see what you mean. The side effects. The side effects. Okay, yes. So in terms of the collaboration, I think one of the key moments for me in getting ready for the clinical trials is if you can imagine that the first dose was given on the 23rd of April of 2020, and in the lead up to that, which is a few months, there were lots of people saying, well, do we really want to make a vaccine? What if it doesn't work, or it's dangerous? And is it a good thing for the university to do? There were lots of people externally saying that this was the wrong thing to be doing. And a Chinese company called CanSino have a very similar type of vaccine. It's a different adenovirus. It's a human adenovirus as their platform, the same spike protein. And they were a bit ahead of us. So they'd got lots of animal data, and they'd also been conducting their phase 1 trial. And so I had a Zoom meeting with them, and they shared all of their data completely openly with me, which I could share with the UK regulator and with the people in Oxford and elsewhere. And that was really reassuring to people to see that this type of product had gone into people and wasn't causing any problems. So I think in that regard, there was lots of collaboration. As we got further through 2020, talking about things was difficult for two reasons. One is that there were journalists everywhere. And so trying to manage messaging was really difficult. I'm not sure we always got it right, but it was very difficult to do that. And the other thing is the sort of slightly funny commercial things that as you get to the point where you're about to release your results, it affects the markets. And so the rules about releasing the data become very around insider trading law and so on. So it's actually quite difficult to share things that, even in the few days beforehand when we knew the results, we couldn't tell anyone. So it's complicated. As far as modifying the vaccines, and you mentioned the myocarditis, there's also the blood clots, the thrombosis, thrombocytopenia. The difficulty is for neither of those conditions, with the RNA and the viral vector vaccines, do we know the mechanism or what we would do to modify the vaccines to avoid them. Now, I think everyone, if that was something you could easily test, if we had the animal models to evaluate it, then I think that would be straightforward, and people would do it. But there's lots of scientists who have said we know what the cause is, but none of that has turned into anything that I'd be confident in. But it's a good question.
Okay, gentlemen, just there, and then I'll put some online questions. I wouldn't do them justice if I didn't ask.
My name is Koji. I'm working in NHS Mental Health Trust. And my question is, being vaccinated and not being vaccinated had an impact on social mobility. Because now working in NHS, some NHS say you should be vaccinated if you want to get a job. But that's also kind of relating to the ethnic minority or misunderstanding. I think maybe may have an impact on the social mobility. Maybe politic, but I just want to know your opinion.
Well, I certainly agree with you that it's definitely a major issue. I'm not sure I've got the solutions. I mean, I think in some ways that difference, particularly in some ethnic minority groups, a very low uptake, is something which was very actively dealt with. There was huge efforts to reach into communities with faith leaders and community leaders to try and support those issues and provide clear information. I don't think it always worked, and of course some groups are very difficult to break into because they're networks that don't really have any outward connection. And there was a doctors' organisation which tried to deal with across medics in the NHS to provide information within various different networked groups that I think was very successful with leaders from ethnically diverse groups taking that role on. I think they did the most amazing job in trying to reach doctors who were uncertain, which is obviously important leadership roles in the community. I'm in some ways, your question brings a great sadness to me, because vaccines are the great leveler, and they should be, in a population like ours here, available to everyone, access to everyone, so everyone has an equal right to health. And I think the pandemic has really opened up this horrible situation that we have with the inequity in our society, and it's not driven by the sort of the desire to be able to vaccinate everyone, but by misinformation that's there in some communities.
I'm going to just turn to some of the questions, because some of them are quite just about you and asking about you. And I want to ask one specifically. So a couple of people have talked about your being part of Barts Alpine Club. And people want to know, how did your training in the Barts Alpine Club help you in your approach to tackling COVID-19 and developing the vaccine? Any tips from that time that came into good use?
Well, since there's some members of Barts Alpine Club here, I need to be slightly careful what I say. But I think, when you consider the, particularly climbing in high mountains and the huge teamwork required to do that, to some extent, people have to understand how to work together to keep each other safe. And there are also people who bring different skills and different roles to the party. And that's very similar to doing team science that we do in the pandemic. So I think that's one thing which comes there. But I mean, the other thing, particularly in the sort of major mountaineering expeditions to Himalayan peaks, the resilience you need to keep going day after day in bad weather conditions and with the physical pressures of it, I think really builds a resilience that partly that it's that you can get through it and get to the end. And no, I mean, I'm not sure that that's something which is always appreciated by the rest of my team, but they were working 7 days a week. Late, everyone is still in late in the evening, but they kept going during that long period of time because there was a shared goal to reach, which was, I think everyone recognised, was very important.
Definitely. Team science all the way. I have a gentleman up there. Oh, sorry. Oh, apologies.
Sorry, I got the wrong way around. So I'm a local GP, and one of the things that we found that came up repeatedly from patients, and I also worked with Downing Street as well, was the lack of BAME and women in the actual trials across the world when both for AstraZeneca and for the other vaccines that were developed, that have been developed. And it's not just the COVID-19 vaccine, that goes for all vaccines. So one of the things that people said is, well, women didn't take part in that. So I don't know how that's going to affect my community. And also from Black and ethnic minority, what are the lessons that you've learned from this pandemic, and how are you going to change that strategy so that future trials for all medication does include Black and ethnic minority people and women, so that we don't face this problem again?
Well, I think the question is a very important one. We actually directly addressed that with the nature of our trials. 2,000 people in South Africa, more than 2,000, they were almost exclusively Black. In Brazil, where we had 10,000 enrolled, the vast majority were from either mixed ethnic backgrounds or in some of the states, for example, in Salvador, again, a large portion who were Black. I think the lessons really are probably UK ones, running trials here, where it's much more difficult to run trials across the whole reflective ethnically diverse population. We find that we always have underrepresentation, if you just advertise and go out, of ethnically diverse or ethnically minority groups. And the solution to that in trials in the US was to stop recruiting anyone who's Caucasian and only continue recruiting in those other groups to make sure that they ended up with a balanced population. And I think that is one way in which that could be done. perhaps the right way around it is to actually be reaching into those communities and providing information in advance so that we're much better able to recruit in wide populations in the future. But across Black, Asian groups in the global trials, we covered all of those in our development for exactly this reason. But as I say, the UK was much more difficult to get proper representation of a UK population. We're a bit below where it should be.
Thank you. And I think leading on from that in terms of future preparedness, as some of the questions online have talked about related to the manufacturing and how do you think, are we collating all this learning? Where is it going? And if we're not doing it, how do we spearhead so we do get that information so that whatever happens in the future, we do truly learn from what we've learned now?
So as far as the equity argument is concerned, there was global agreement by politicians and led by the World Health Organization about how we should vaccinate the world. But then national politics trumps that. Because, you know, if you're an elected politician in a democracy, your duty is to protect your population. It's unacceptable to have people dying in your country whilst you're giving your doses to another country. And so that means there's a real challenge if you have ownership of doses in being equitable in the way they're distributed. So I think we have to move towards a situation where in international law we've dealt with this in advance and we know how we're going to manage it. The other side of it is to make sure that those underserved parts of the world have their own manufacturing. And this, of course, for Africa has been the biggest problem, that there is very little manufacturing in Africa. And I think there is a huge drive to change that now. There's already some investments started. There's buildings being put up to start manufacturing. But it has to be a long-term investment. It's not just build a building and train some people now. You've got to have those perhaps in 10 years or maybe in the next 100 years when the next pandemic is, and sustaining both the equipment and the skills of the staff between the pandemics, I think is going to turn out to be the biggest challenge. How do we do that, particularly for Africa?
Yeah, thank you. Now, I'm really mindful of time and I can take one more question from the audience. I'm going to look in this direction here. So
I am wondering how it is that you and your lab perhaps are preparing for the future. What are you actually looking to in terms of the next pandemic, or in terms of how you might change your platform, or even the way in which you look to conduct trials?
So the first thing that we're already doing is working across a long list of different bugs that cause outbreaks that could be global threats in the future. And that's part of what I was saying about being ready for whatever comes next. And if you've understood across lots of families of viruses how to make a vaccine for them, then hopefully whatever comes at you, you've already got at least the template of what you need to do, like we had with coronavirus. So that's a really important bit of the work. And the UK government has a list of what its priorities are. WHO has a list. And so we're trying to cover that list. I don't think in the long run that's enough, because it seems very likely that we could be a virus that we weren't expecting. And so understanding the rules that perhaps mean that even with a completely novel genetic code of a virus, you can predict exactly which bit of it to make the vaccine from. And I do think we could do that work over the next 5 or 10 years. No one's investing in it at the moment, but I think to me that's a critical bit to make sure that we're ready, that we really understand the biology much better for the future. I'm not sure that completely answers the question.
Thank you so much. Apologies, but I think we're going to have to end there. But I just want to thank you just for being so open and answering all our questions. And I think that for me personally, just to have you here and talk through listen to all your experiences, it's definitely going to inform the way that when I'm conveying to people about how the vaccines were developed and how it should be integrated, looking to the future, I've had my personal lesson here. So really, really grateful. And I'm sure all the audience will agree with that. So thank you so much. Professor Sir Mark Caulfield to give our closing remarks.
Thanks, Vanessa. Well, Andy, what can I say to follow that? I'm Mark Caulfield. I'm Vice Principal for Health here at Queen Mary. Didn't the boy do good? One of our own, welcome home. It's been a privilege to have you back. To all the medical students here, this is you in years to come. We're expecting great things of you.
Just a few years.
No pressure. Just a few years. Just a few years. Yes. He wasn't here in 1123, and nor was I. Just to correct the record. So, what an extraordinary story! It's an amazing journey, and we're so very proud of what you've done. Not just for the whole of humanity in bringing a vaccine forward that has changed the course of it. It may surprise you to know that actually during the pandemic, we did enroll quite a lot of people in various trials, the recovery trial, one of the trials from Oxford. But one of our most unusual experiences here at Queen Mary and at Barts Health was to be rang up by Dame Kate Bingham, a force of nature, and instructed to prepare a vaccine trial centre. So what we did was we immediately did public and patient engagement, and that told us that nobody in East London would come near our clinical research centre in the hospital. So we had to base this in the community, and within 6 weeks, we moved the books to one side and opened a trial centre in Bethnal Green Library, would you believe, and enrolled over 800 people in a matter of weeks through that facility. But I'm sorry, Andy, we gave them the Janssen vaccine. I apologise. But the good news is that through excellent work by a partnership between Barts Health and Queen Mary, we were able to enroll 27% from our minority communities. And you're not going to believe one of the most successful routes to enrolment was that when the library was normally a library and open, this was where you could get free food and vegetable disposable compostable bags. So several people would come in every day and say, what's going on here? And then be enrolled in the trial while they collected their free disposable compostable bags. So on behalf of all of us, Vanessa, Andy, on behalf of Colin, Queen Mary University of London and Barts Health, thank you so much. There are refreshments beckoning outside. Please do ask Andy some questions as you enjoy the refreshments. And thank you so much, Andy, for a wonderful lecture. Thanks a lot.
Thank you. Thank you.